Hey there, CJ Math students, and welcome to Notes 4.2, Part 1. So just like we did yesterday, I want you to make sure that once I do a question, pause the video and then do the question on BuzzMath. Your content scores were much higher than usual because you used that strategy, so please trust the process and use the strategy today. So we have two different types of expressions. A numerical expression, which contains only numbers and operations, and that is compared to an algebraic expression which contains numbers, operations, and the only difference between the two is that algebraic expressions contain variables. All right, those crazy looking letters that we're like, what are those all about? All right, so number one, what value does the numerical expression 3 plus 5 represent? That's easy. 3 plus 5 is 8. The value is called the sum, right? When you find the answer to an addition problem, it's the sum. So now, which numerical expression represents a value of 25? So add them all up. So 11 plus 14 is 25, so boom, that's one. 3 plus 8 is 11, plus 14 is 25, so boom, that's another one. 5 plus 7 plus 19, no, that's not one, that's equal to 31, so no. 12 plus 14 is equal to 26, no. 11 plus 5 plus 9, that is equal to 25, because 5 plus 9 is 14, plus 11, I know 11 plus 14 is 25, and then 19 plus 12 is 31. So you have three answers here. You should probably have three answers on yours. So again, pause this video. You may use the calculator on this level. Pause this video and do problem number one. All right, problem number two. A variable is a symbol that can represent different values. Basically, a variable is a number we don't know yet. So it's a placeholder, basically. We hope to find out that number, but sometimes, we don't know it, and so in math we can put down a letter, aka a variable. So what's the variable in x plus 16? It's just x. What's the variable in 13 minus n? It's just n. And what's the variable in p plus 17? It's just p. Very simple, right? In the expression x minus 4, when x equals 11, what is the value of the expression? Well, you just plug in 11. 11 minus 4, so the value is equal to 7. And this is called, the answer to a subtraction problem is called the difference. You have one more part on number 2, and that's part C, and it's just asking the same thing as B, right? In the expression x minus 4, when x equals 10, what's the value of the expression? So just plug in 10 for x, 10 minus 4, the value of the expression is equal to 6. Okay, so again, pause the video right now and go to number 2 on BuzzMath. All right, number 3. This is where we start to kind of get vocab heavy, so really focus in here. An expression consists of terms. The terms are separated by either a plus or minus sign. So a term is just a number, a combination of a variable number, or just a variable. So for instance, this is a term separated by a plus sign, and this is a term. So this expression has two terms, so we matched it up with this guy right here. This expression has 1, 2, 3 terms. This expression, p, a variable all by itself, is a term. 16p, a term. 26, a term. And all by itself, a term. So it has 4 terms. So obviously the last one has 1, 2, 3, 4, and 5, all right? It doesn't matter if it's got like 2 variables like np, that doesn't count as 1 and 2 terms. Just anything separated by a plus or minus sign counts as a term, okay? Now, a constant or a variable, a term can be a constant or a variable, excuse me. A constant is a numerical value with no variable, right? It's basically a number all by itself. Okay, so if I say identify the constant in the expression, you're just scanning through all the terms and you're saying, okay, where's the one that just has a number all by itself? Well, that's a variable. That's got a number, but it's attached to a variable. 26, that's all by itself, right? It's separated by a plus and minus sign between the next two terms. And x, that's a variable all by itself. So the constant is 26, okay? So I'm pretty sure you would ask to be typing 26 on BuzzMath, right? And lastly, a coefficient is in a single term containing a number and a variable. The number in front of the variable is the factor of the variable, and it's called the coefficient. Basically, all you got to know is a coefficient is a number in front of a variable. Otherwise, a number could also say attached to a variable by multiplication, right? So for instance, identify the coefficient in the term -3/5 x. So it doesn't have to be a whole number. It can be a fraction. So the constant includes both the fraction or number and its sign. So this minus sign, when you plug it in on BuzzMath, is really -3/5. It might be super helpful when doing all these expressions to go through and say plus and negative to everything. So every minus sign you change into a positive sign, adding the opposite. So like plus a negative, right? And we'll talk about what the negative in front of the x means, but there is your coefficient. Sorry, there's your term, and then your coefficient is just the -3/5. It's attached to x, okay? So -3/5 would be your answer there. All right, pause this video or even rewatch it, this part, and then do question 3. Question 3 is long, okay? All right, number 4, like terms have the same variable and, very important, and same, sorry, I'm running out of space, exponent, okay? So I'm going to give you a couple examples, like 2x and 3x. Those are like terms, right? 2x squared, however, and 3x, those are not like terms. Why? Because this one has an x squared and that one just has an x, right? This is like saying I can add 2 red apples and 3 red apples, but I can't add, 2 red apples that have green leaves at the top of them and 3 red apples that don't. They have to be exactly the same thing if I want to say that they are like terms, okay? So x and r, those are not like terms. They're not the same variable. 5r and r. You might be like, well, those aren't like terms because one's got a 5. No, look at the definition. They only have to have the same variable and same exponent. Do they have the same variable? There's an r, there's an r. Do they have the same exponent? Well, they don't have exponents. So yes, they have the same variable and same exponent. Okay? 6r squared and r. Are they like terms? You might be like, well, yeah, they both have r's, but look at this one. This one has an exponent of 2, and that one doesn't have an exponent. All right? So they not same exponent. So therefore, they are not like terms. Right? 6r squared and 5r. Just like this one. This one's got an r squared. That one does not. So again, not like terms. 6r squared and x. Well, look at that. They got a variable of r and a variable of x. You can't add r's and x's. Those don't make sense. Okay, so not like terms. And here you have 6r squared, r, and 5r. Again, tempting to say, oh, they're like terms, but this one has an r squared and this one. So those two would be like terms, but it's asking if all 3 are like terms. So no. All right, to simplify, again, just like I said, what you're going to want to do is go through and see any minus signs and say plus a negative sign. Also, any variable left by itself has a coefficient of 1. Why? Because like how many v's do I have there? Well, I have 1 v, okay? So you always go ahead and put like a coefficient of 1 in front of it. So now we go through and say, okay, plus a negative. Any other minus signs? No. And now we just scan through and say, okay, what are the like terms? Well, this is a 3v. Do I see any other v's out there with no exponents? Yeah. Here's a -1v. Oh, and there's 5v. Okay, so now let's add up the like terms. Let's add these two first. 3 plus -1 gives me 2v. All right, plus 6 plus 5v. And do I have like terms still? Yeah, I do. I have 2v and 5v. 2v plus 5v is 7v plus 6. That would be your answer. There's nothing to solve. There's not going to be any final answer. I can't add 7v and 6 because those are not like terms. This has got a v, and that does not have a v. So it wouldn't be 13v. This is your final answer. An expression will be your final answer. This is tricky, so I'm going to do another example even though BuzzMath doesn't do one. All right, so again, I see a v all by itself or a variable all by itself, so I put a coefficient of 1 in front of it to say, hey, I have 1v there. My minus sign, I'm going to do plus a negative, and then I'm going to look through and see all my like terms. So I have a 6v, a 1v, and an 8v, a -1v, right? So 6 plus -1 gives me 5v plus 7 plus 8v. Now I look again. Do I have any more like terms? Yes, I do. 5v and 8v. So that gives me 13v plus 7. That's my answer. Not 20v, right? You can't add 13v and 7, right? Those are unlike terms because that one doesn't have a variable of v. Okay, pause this video and do number 4. This is also the end of part 1 video.